Hey there, guys. Looking at section 3.3 today. We're actually talking about average rates of change, and then I'm going to add in a piece about increasing and decreasing intervals. So there will be a couple things that I kind of just add in. So if you feel like you need to write them down, you certainly can. When we talk about rates of change here, rate of change, we think about that idea of slope of the line between 2 points, or your change in your y over your change in x, which can kind of a weird idea to think about with a curve. Since we can't find the slope of a curve, right? Because it's not slope of a line. But what we can do is just think about the average rate of change. So if I'm looking at how does the curve change from like this point to this point on average, or I could even look at how's that change from this point to this point on average. And so if we think about that idea of an average, we can think about the line between those 2 points. Again, just kind of like getting an idea of how things are changing, though it may not be very exact. So we're going to start off with looking at a graph to do this, and then we're going to move on to the more like abstract, where we can do it without having a graph. So start with the more concrete part, and then move on to the more abstract. So when using a graph, it's asking us to find the average rate of change over the interval from -1 to 2, right? So these are our x values. And so the first thing we want to do is think about what's the output for each x value. So when I plug in -1, what do I get? So what is f of -1? So remember how you do that? You go to where x is -1, since that's our input, and then we go to where the graph is at that input. So this graph has an output of 4 when the input is -1. This function has an output of 4 when the input is -1. And same thing here. So then go to the other end of the interval, so in this case 2. So what's f of 2? And so looking here, x is 2, and then y is 1. So the output for 2 is 1. So the idea here is we're going to, if you kind of sketch out the line that goes between those 2 points, we're going to think about essentially what's the slope of that line. Okay. So remember what slope is. It's the change in y over the change in x. And change is a subtraction idea, right? y2 minus y1 over x2 minus x1. And with doing this, you should always go from left to right. So this would be 0.1 and this would be 0.2. So this would be our output to our y2 would be the 1 value. And our output for the first point would be the 4. Oops. And then the x value for the second point would be 2. And then the x value for the first point would be -1. So we just need to do this math. Of course, 1 minus 4 is -3. 2 minus -1 would be +3, which would then reduce to -1. And so, think about what we found. We found the average rate of change over the interval from -1 to 2, and it is -1. So again, the idea is that for every 1 x value we go over, we're going down 1 y value on average. That's how you use a graph to do that. What if we don't have a graph of the function? How do we do it? It's the same way. I want to start by looking at the x values they're asking us to use. So in this case, it would be from 1 to 9. Right? Those are our inputs. And so then we want to evaluate the function for each of those inputs. So find f of 1. Make sure you're using the right function here. So plugging 1 into that. So that would be 1 minus 2 times the square root of 1. Of course, that would be 1 minus 2 2 times 1, square root of 1 is 1, and then that's 1 minus 2, which is negative 1. Do the same thing for 9, so f of 9 equals 9 minus 2 times the square root of 9, which would be 9 minus 2 times 3, which is 9 minus 6, which is 3. So then I want to find the rate of change there, right, the slope between those 2 points. So take that second y value, right? We always want to go from the left point to the right point, so that's second y value. So the y value associated with 9, which is 3. The output associated with 9 is 3, and that goes with 9. And then the output associated with the 1, which was negative 1, and the input was 1. So 3 minus negative 1, which of course is 4. And then 9 minus 1, which of course is 8. And 4 divided by 8 is 1/2. So there's our rate of change over that interval. So for every 2 points we move to the right, we go up 1 point. What that means, right? For every increase in 2 x's, we go up 1 y value. We can also do this over an interval that doesn't have a specific value. We can find it kind of more in general terms, so we can go from 5 to a. I'll treat it the same way. Again, want to start on the lefter side of this, the smaller side of this, so 5 being that. So I'm going to evaluate the function for 5. And so 5 squared plus 2 times 5 minus 8, which of course is 25 plus 10 minus 8, which is 35 minus 8, which is 27. Then I want to plug in a, so f of a, which is actually easier. Because, as we go to try to evaluate it, a squared is just a squared, and 2a is just 2a, and minus 8. So there's our output. We're going to plug a in, we get that out. So remember, finding that rate of change, finding that slope is, so remember, start on that. Start on the left, that's our 1, and so we want to actually use the values from the second input first, and so our second input was a, and the output from that was a squared plus 2a minus 8. Now, because that's all coming from one place, I do want to put that in parentheses up there. And then the first input was 5, so that's my x1, and the output for that was 27. I'm going to go ahead and put that in parentheses too, just because of what we're doing up at the top. But so I need to simplify this. So of course the bottom is just a minus 5, the denominator. Here in the numerator though, a squared, no like terms, 2a, no like terms. So negative 8 minus 27. So be careful with your subtraction there. But the numerator starts off with a squared plus 2a. Negative 8 minus 27 is negative 35. So we end up with this rational expression here, and what we talked about in section 1.6 was with rational expressions, we do need to see if we can reduce those. And that's all about that idea of can we factor this so that we can reduce. Right? We're not allowed to just take these a's out. That's not okay. Or not allowed to do this here. Division is the opposite of multiplication, and these things are adding and subtracting up here, so division cannot act right now. If I have something times something else, then I can divide it out. So I need to look at that numerator and see if I can factor it. So see if there's something that I could divide out a common factor with the denominator. So this should be shortcut AC method since a value is 1. So 1 times negative 35 is negative 35. And we need negative 35 to add to 2. So what are the factors of negative 35 to add to 2? That would be 7 and negative 5. So it does indeed factor. So, and again, shortcut AC because the A value is 1, so we can say that's A plus 7, A minus 5, all over A minus 5. And lo and behold, we have a common factor of A minus 5. So our average rate of change is just A plus 7. And so what that allows, why would we want to do something like that? Why would we want an A there? Basically what we just said, set up a formula like that no matter what we plug in. So if we said, hey, if I want to go from 5 to 10, well, I would know the rate of change now would be 10 plus 7. The average rate of change would be 17. If I wanted to go from 5 to 30, the average rate of change would be 37. So allows us like a formula that would let us figure that out quickly. We don't have to do individual calculations. So you guys will have a problem like that where you have to plug in a variable and then make sure. So watch out with that factor in there. Make sure you factor that. Again, I believe you should be able to use shortcut AC because your A value will be 1, but just watch out for that. Alright, so that's it for the rate of change stuff. Next part is increasing, decreasing. This is definitely something we went over in Algebra 2. If you're coming straight out of Algebra 2, but it would have been like one of the very first things we covered in that class. And it tends to be something that can be a little sticky. What we're doing with this is we're going to use the graph to estimate intervals on which the function is increasing or decreasing. Okay, so we're using interval notation still. And so what does it mean for a function to be increasing? Okay, so we say a function is increasing on an interval if as the input values increase, the output values also increase. So as our x's increase, our y's also need to increase. So when we think about x is increasing, that means we're moving from the left side of the graph to the right side of the graph. Right? And my x values are going up as I do this. So are the y values also going up as I move from the left to the right? So make sure we're always reading left to right. Right? If a function is decreasing on an interval, the input values increase, so we're still moving from the left side to the right side, but now the output values are decreasing. So as I move from the left to the right, are my outputs increasing or decreasing accordingly? Okay. So what I'd suggest you guys do for this, so it's going to usually ends up involving you not necessarily answering the question in the order that it's asked, but I think it's a little bit easier to kind of visualize until you get a hold of it. Since we're always so focused on those input values increasing, we want to start on the lowest input value, which means we're going to start on the leftist side of the graph. So always start on the left, okay, just like we're reading domain, okay? And so I'm starting on the leftist part of the graph, and as I try to follow it right, I want to stay on the graph, but I want to move to the right. What else am I forced to do? Right? So in this part of the graph, I'm forced to go up as I try to move to the right. So this interval of the graph is increasing until right here. And then as I try to move right now it starts to drop. So I'm following the graph, but I'm forced to move down as I move to the right until there, right? And then something changes. And now as I keep moving right, now I'm increasing again. Okay? So I had an increasing portion of the graph, interval, right? Another increasing interval, and a decreasing interval. So what you can't do is just look at arrows. Like this arrow is pointing down. Oh, it must be decreasing. Nope, that's not how it works. As I move from left to right, what do the y values do? The y values increase. As I move from the left to right, the y values decrease. As I move from the left to the right, the y values increase. So tricky thing here is, right, we're looking at how y is moving up and down, but the question is always about x. What x values make the y values increase? Okay? And so we got to look up and down, but we have to talk left to right. There's an increasing interval. What x values are increasing? So it starts at negative infinity because that's pointing to the left. I don't care that it's pointing down. I care that it's pointing to the left. And it increases all the way until, make sure you look at the x value. Right? That x value is negative 2. So from negative infinity to negative 2, we have an increasing interval. Okay? And you always use appendice here, because at that point, after that point, it does not increase. So we cannot include that value in there. Okay? So those points of inflection, those turning points will never be included. Here it's always going to be parentheses. And then so as I keep moving right from there, now I'm decreasing to here. Where did I start decreasing? Again, pay attention to the x value, not the y value. So from -2, from -2 all the way to, again, what's the x value there? Looks like it's 3. So from -2 to 3, we're decreasing, and then something happens at 3. From 3, it starts increasing again, and then it goes right forever. Again, I don't care that this is moving up. I care that it's going right. So from 3 to infinity, because it's going right forever. So because this has 2 intervals here, there's this part that's increasing, there's also this part. You can, what I noticed from the computer programming, you can separate those with a comma, or you can also use the union notation. So either way, when you need to separate multiple intervals like that. Okay, so make sure you're only talking about x values, right? What's the x? I don't care how high it's increasing to or how low it's decreasing to. I care when it's doing that, right? What x values make it go up? What x values make the y values go down? What x values make the y values go up? Okay, so these are only x values we're talking about here. Let's try that again. Right, use the graph to estimate when the intervals or with the function is increasing and decreasing. Again, what I would just suggest you do is start on the leftist point of the graph and try to move right. So as I move right along the graph, I'm having to decrease till right here. So this portion of the graph is decreasing, and then right at that point it starts to increase again. So a lot of times we look at those arrows and say, oh, it's just increasing. All right, nope. This portion of the graph is decreasing, and this portion of the graph is increasing. So I have to identify that first, and then I can go and write my answers. So it's increasing. Where did it start increasing? Right here. What's that x value? That's 4. And it keeps increasing to the right forever. Those were parentheses there all the time. Then it was decreasing. Where did it start decreasing? It started decreasing at negative infinity because that's pointing to the left. And then where did it stop decreasing? Stop decreasing at 4. Right, not how low did it go? What x value did it stop at? Right. One more of these, we'll be done. Use the graph to estimate the intervals which the function is increasing and decreasing. So on, you guys will have a graph or two where the points don't, those inflection points don't match right up to a number. So that idea that you're estimating. So they shouldn't be anything crazy. They should be pretty easy to tell what they are. So again, I'm just going to kind of look at things out. So the first thing I notice as I start on that left side is I'm dropping. So I have a decreasing interval. And then it turns and starts to increase for a little bit. And then it turns again and starts to decrease again. Okay, so I want to identify where it's increasing. So where did it start increasing? It started at 0 again. Make sure you're focusing on that x value. That's x value of 0. Where did it stop decreasing? Looks like that's at 1.5. Parentheses on both of those. Where is it decreasing? So left side, that left arrow, so negative infinity, stopped at 0. Again, that x value. And then again, you can use the comma or the union symbol for this. Where did it start decreasing again? Started decreasing again at 1.5 and kept going to the right forever. So from 1.5 to infinity. So again, what you're asking yourself here is what x values make the y values decrease. So as I move from negative infinity to 0, the y values will get lower and lower and lower and lower and lower. As I move from 1.5 to the right forever, the y values will get lower and lower and lower. Right? as I move from 0 to 1.5, the y values are increasing as I move along this way. Right? Y values are going up. Not how high or low are they getting, but just when is that happening. So in this space, they're increasing. In this space, they're decreasing. All right, hopefully that makes sense. Of course, let me know if something's not. Enjoy the rest of your day.